Today's lesson, Basicity of acids. In this lesson, we are going to learn acidity of bases in short, Bronsted-Lowry acids and bases, and finally basicity of acids in detail. So let's begin. First of all, let's see acidity of bases. It's a kind of base. When it is dissolved in water, it ionizes to sodium ion and hydroxide ion. So this base produces one hydroxide ion in water. So its acidity is 1. Similarly, if we take magnesium hydroxide, if it is dissolved in water, then we get magnesium 2 plus and 2 hydroxide ions. Since magnesium hydroxide produces 2 hydroxide ions, so its acidity is 2. Similarly, if we take aluminum hydroxide and if it is dissolved in water, then we get aluminum 3 plus and 3 hydroxide ions. Since aluminum hydroxide produces 3 hydroxide ions, so its acidity is 3. Now let's see the definition of acidity of bases. The number of hydroxide ions that is produced from a particular base in aqueous solution is called the acidity of the particular base. If the hydroxide ion is 1, then its acidity will be 1. If it is 2, then acidity of this base will be 2. If it is 3, then acidity of this base will be 3. So this is acidity of bases in short. That means number of hydroxide ions produced in aqueous solution by a particular base is the acidity of the base. Let's see the next point. Now the point is Bronsted-Lowry acids and bases. Let's see which compounds are Bronsted-Lowry acids and which are Bronsted-Lowry bases. Bronsted-Lowry acids are hydrochloric acid, nitric acid, sulfuric acid, phosphoric acid H3PO4, phosphorus acid H3PO3, hypophosphorous acid H3PO2, etc. And Bronsted-Lowry bases are ammonia, hydroxide ion, etc. Now let's see the definition of Bronsted-Lowry acids. The hydrogen containing compounds that produce protons, those compounds are called Bronsted-Lowry acids. And Bronsted-Lowry bases are the compounds that accept protons produced from Bronsted-Lowry acids. Those compounds are called Bronsted-Lowry bases. Now let's see the number of protons produced from different Bronsted-Lowry acids. Hydrochloric acid produces 1 proton, sulfuric acid produces 2 protons, phosphoric acid produces 3 protons, acetic acid produces 1 proton. So different Bronsted-Lowry acids produce different number of protons. This matter is known as basicity of acids. Now let's see the basicity of acids in detail. Now the point is basicity of acids in detail. First of all, let's see basicity of some acids. Hydrochloric acid, its basicity is 1. Nitric acid, this is 1. Sulfuric acid, basicity is 2. Phosphoric acid, basicity is 3. Phosphorus acid, basicity is 2. Then hypophosphorous acid, basicity is 1. And acetic acid, basicity is 1. Now let's see the definition of basicity of a particular acid. The definition is the number of ionizable hydrogen atoms or replaceable hydrogen atoms by a base is called the basicity of the particular acid. That means the number of ionizable hydrogen atoms or the number of replaceable hydrogen atoms by a base. This is basicity of a particular acid. The number of hydrogen atoms present in the molecule is not the matter. The matter is the number of ionizable hydrogen atoms or replaceable hydrogen atoms. This is the basicity of an acid. Not that the total number of hydrogen atoms determine the basicity of acid. Rather, the number of ionizable hydrogen atoms or replaceable hydrogen atoms by a base determines the basicity of an acid. Now let's see how the basicity of these acids are these types. Let's see in detail. Now let's see basicity of different acids are different. It doesn't depend on the number of hydrogen atoms. Rather, it depends on ionizable hydrogen atoms or replaceable hydrogen atoms by a base in a particular acid molecule. Now let's see why the basicity of hydrochloric acid is 1. This is the structure formula of hydrochloric acid. Here electronegativity of chlorine is 3.0 and hydrogen is 2.1. So the electronegativity difference between hydrogen and chlorine is quite high, and for this reason the covalently bonded electrons move towards chlorine, and this bond, hydrogen chlorine bond, undergoes a heterolytic fission, and at one stage this hydrogen gets freed as proton. So this is the molecule can yield only one proton. That means in this molecule only one replaceable hydrogen or ionizable hydrogen atom is present. That is why its basicity is 1, because here only one ionizable hydrogen atom present. But another term is used, that is replaceable hydrogen atom by a base. When this acid is added to a base, then this hydrogen is replaced by metal like this, sodium chloride and water. That means this hydrogen is replaced by sodium. That is why it is said that the number of ionizable hydrogen atoms or the number of replaceable hydrogen atoms by a base, this is basicity of an acid. Let's see another example. Now let's see the basicity of nitric acid. The structure formula of nitric acid is this. This is coordinate covalent bond. Here the electronegativity of oxygen is 3.5 and hydrogen is 2.1. The electronegativity difference between hydrogen and oxygen is quite high. So this bond undergoes heterolytic fission and this hydrogen is released as proton. So nitric acid has only one ionizable hydrogen atom. That is why its basicity is 1. Again, when it is added to base like sodium hydroxide, then this hydrogen atom is replaced by sodium metal and the compounds are sodium nitrate and water. So nitric acid has only one ionizable hydrogen atom or replaceable hydrogen atom by a base. That is why the basicity of nitric acid is 1. Let's see the basicity of sulfuric acid now. The structure formula of sulfuric acid is this is the structure formula of sulfuric acid. Here this bond undergoes heterolytic fission. At the same time this bond undergoes heterolytic fission. So this hydrogen is released as proton. At the same time this hydrogen is released as proton. So sulfuric acid has 2 ionizable hydrogen atoms. That is why its basicity is 2. Again, if it is added to sodium hydroxide, then these 2 hydrogen atoms are replaced by the base, that is sodium, and these compounds are formed, that is sodium sulfate and water. So 2 hydrogen atoms are replaced by 2 sodium atoms. So in this compound there are 2 replaceable hydrogen atoms or 2 ionizable hydrogen atoms. That is why the basicity of sulfuric acid is 2. Let's see another acid. Now basicity of phosphoric acid. The structure formula of phosphoric acid is HOP. This is oxygen, hydrogen, hydrogen. That means H3. This is phosphoric acid, H3PO4. H3PO4. This is phosphoric acid. Here this bond undergoes heterolytic fission. This bond undergoes, and this bond undergoes heterolytic fission. So all 3 hydrogen atoms are released as protons. So the basicity of phosphoric acid is 3 because this compound has 3 ionizable hydrogen atoms. Again, if it is added to base like sodium hydroxide, then all the 3 hydrogen atoms are replaced by base in this way, that is sodium phosphate plus water. So these 3 hydrogen atoms are replaced by 3 sodium metal. That is why the basicity of phosphoric acid is 3. Now phosphorus acid, H3PO3. This is phosphorus acid. Its structure formula is H3PO3. This is phosphorus acid. Here this bond undergoes heterolytic fission because of the high electronegativity difference, and this bond undergoes heterolytic fission. But here the bond between hydrogen and oxygen remains intact because the electronegativity of phosphorus is 2.1 and hydrogen is 2.1. That is why this bond doesn't undergo heterolytic fission and it is not produced as proton, but other two hydrogen atoms are released as protons. That is why phosphorus acid, though it has 3 hydrogen atoms, but its basicity is 2, because out of 3 hydrogen atoms, 2 hydrogen atoms are released as protons, and if it is added to sodium hydroxide, that means base, then these 2 hydrogen atoms are replaced by sodium in this way. Sodium monohydrogen phosphite, sodium disodium monohydrogen phosphite. This hydrogen atom is not replaced by base. That is why its basicity is 2, not 3, though it has 3 hydrogen atoms. Let's see another acid. Now the acid is hypophosphorous acid, H3PO2. Hypophosphorous acid. Let's see the structure formula of hypophosphorous acid. This is phosphorus with oxygen. Here this hydrogen, another hydrogen and another hydrogen, H3PO2. In this case, this bond undergoes heterolytic fission and this hydrogen is released as proton. But in this case and in this case, these bonds are not polarized because of the no difference in the electronegativity between hydrogen and oxygen. So only this hydrogen is ionizable hydrogen. That is why the basicity of hypophosphorous acid is 1. If it is added to sodium hydroxide base, then this hydrogen is replaced only by sodium, and then the compound is sodium dihydrogen. This compound is formed and water is formed. So out of 3 hydrogen atoms, 1 hydrogen atom is replaced, but 2 hydrogen atoms cannot be replaced. That is why the basicity of hypophosphorous acid is 1, though it has 3 hydrogen atoms. Nevertheless, its basicity is 1. Let's see another acid. Now the acid is acetic acid. It has 4 hydrogen atoms. Nevertheless, its basicity is 1. Now let's see how its basicity is 1. Let's see the structure formula of acetic acid. This is the structure formula of acetic acid. Here, this bond is polarized and undergoes heterolytic fission because the electronegativity difference between oxygen and hydrogen is quite high. That is why this bond undergoes heterolytic fission and this hydrogen is released as proton. But other 3 hydrogen atoms, here the electronegativity of carbon is 2.5 and hydrogen is 2.1. Here electronegativity difference is negligible. That is why these hydrogen carbon bonds are not polarized and no heterolytic fission occurs here and no protons are produced from these 3 hydrogen atoms. That is why the basicity of acetic acid is 1, though it has 4 hydrogen atoms. And if it is acetic acid is added to sodium hydroxide, then only this hydrogen is replaced by base, that is sodium acetate and water. So these 3 hydrogen atoms remain unchanged. Only this hydrogen atom is replaced by base. That is why the basicity of acetic acid is 1. Now let's see the definition again. The number of ionizable hydrogen atoms or the number of replaceable hydrogen atoms by a base in a particular molecule of acid is called the basicity of the particular acid. This is all about basicity of different acids. No more today. Thank you very much.